Hello everyone. So this is me Maurya again, and today I learn about the bridge design pattern. So before moving further, let's understand firstly that this bridge design pattern is used for some specific use cases. So it is not something like I can use it anywhere or everywhere. There are some specific use cases for which I will be using this bridge design pattern. And that specific use case is when I'm dealing with two dimensions or when things vary. Example, let's suppose I am designing a remote control system, and for that I need a remote and a device. So how will I be designing that? I will be creating two. So basically, let's understand there is some devices and remote, and I have device like TV, radio, fridge. If I have to add some other device like mouse, then I can add mouse here. And there are remotes. Remotes are basically three categories I have created: basic remote, advanced remote, and a voice mode remote. So how we will be designing that if I do not know about the bridge design pattern? So basically I will be creating a basic remote control function that will say power on or power off, and I will first create a basic TV remote, basic advanced TV remote, and a voice TV remote. Then I will be creating a basic radio remote, advanced radio remote, or a voice radio remote. Or there will be another remote, basic fridge remote, advanced fridge remote, or voice fridge remote. So in that way, I am creating a lot of classes. That is not required. Why that is not required? Let's see. So basically, there is a basic class that has three choices: TV, radio, fridges. So I will be creating that. In same way, advanced TV, advanced radio, advanced fridge TV. So in that way, I am creating nine classes. And suppose one more class is added here, four. Then I will be creating four into three equal to 12 classes. So there is a basically if it has m and n values, then I will be creating m cross n classes. That leads to class exploitation. Okay, there is class exploitation. What else? This remote and this TV, they are separate. So I can treat them independently. Now I will treat them independently, and but they are somehow connected to each other, and that connection that established between them, this is what bridge is. So this is the idea behind the bridge pattern, is that there is some concept and we are dividing that concept independently into two parts: high level part and a low level part. This high level part we call it as abstraction, and it has the reference of this low level part. It has the reference of this low level part, the bridge reference, the bridge, and the low level part. It is called the implementation, or the implementation of all those things will be there in this part. And in my our example, the low level part is the device and the high level part is remote. Like how this remote look from the outer surface, how this remote looks from the outer surface. So how will I design that? There will be a device, and there will be a remote, and these two will be separate entity, and they will be connected via a bridge, and that bridge will be there in the abstract layer with a reference. How? So this is a device, and the device is has two features: turn on or turn off, and this TV will extend that radio, or it will implement this. How will it implement? The TV will implement its own turn off or turn on. Radio will be turning on, turning off in other way, in its own ways, and fridge will be there with its own way. These are all the implementation how we see it from the outside. But how this remote looks like? Remote has a reference of this device. There will be a power on off button, whatever this requirement is, and I will be implementing the basic remote, and this will call out the constructor of this reference. It will be of TV or radio or fridge. This will be calling out that, and in it there is a power button that has device on or off. I can on it or off it. So yeah, in this way I am implementing this bridge design pattern. If I have to add another remote type, I will add this. Suppose it is a kabutar remote. So kabutar will be added here and I will be using it or whatever will be there. Now the question arises that why I have taken it as abstract. Why not the interface? Because I am also extending it na. Uh, Question is valid. So I am using it as abstract because I want to implement some methods also in here. The interface is something like I am just creating you a template. I am not implementing anything inside that. But I am creating it as abstract because I am using it the device in here and also initializing that. So the abstract is used here. Now how will I use this? Suppose I want to use the basic TV remote. So what I will be doing is there will be a remote. Let's call it as basic TV remote. Then new basic TV remote. Inside that I will pass the function new object of the TV remote. Let's suppose I want basic radio remote. So I will be doing basic remote. Inside that I will pass on the radio. And then basic TV remote dot power. It will turn off or on whatever will be there. It will do its job. Now this code looks a little bit messy. Let's understand it. So basically, I have written new basic TV, new basic TV. So how will it run? Firstly, this there will be a basic remote. This basic remote is calling out this super or the constructor, this device, and what is present in this device? The reference of the TV. Okay, and in the power method, the device turn on or off we are doing. So this device has the reference of this TV. If there will be a refrigerator, so this device will be pointing to the refrigerator, and this device has the reference of that refrigerator. So it will turn on it or off. So this is all about this bridge design pattern. And if I have to formally define what bridge design pattern is, it is basically we are splitting the two-dimensional related classes into two separate hierarchy. One is called the abstraction and one is called the implementation. And this abstraction has the reference of the implementation, which we are calling as a bridge, and they can be developed independently. So this is the definition. One another definition is that I do not understand, so I don't want to understand it, but it is written. So it separates the abstraction from the implementation so that they can vary independently. So yeah, this is all about the bridge design pattern. That's it from my side. Bye bye.